Hi, I am Dr. Ajay Kumar. I work as an assistant professor in the Department of Journalism and Mass Communication, Himachal Pradesh University. Today I will discuss with you over the topic extended reality. Paul Milgram defined the well-known reality-virtuality continuum in 1994. It explains the transition between physical world on the one hand and a complete digital or computer-generated environment on the other hand. However, from a technology point of view, a new umbrella term has been introduced named extended reality, often referred to as XR. It is the umbrella term used for virtual reality, augmented reality, and mixed reality, as well as future realities immersive technologies might create. Extended reality covers the full spectrum of real and virtual environments. The reality-virtuality continuum is extended by the new umbrella term. As seen in the figure, a less-known term is presented, called augmented virtuality. This term relates to an approach where the reality, for example, the user's hand, appears in the virtual world. Now, let's have an overview of the terms related to extended reality. Augmented virtuality, augmenting the perception of a virtual environment with real elements. These elements of the real world are generally captured in real time and injected into the virtual environment. The capture of the user's body that is injected into the virtual environment is a well-known example of augmented virtuality aimed at improving the feeling of embodiment. Virtual reality applications use headsets to fully immerse users in a computer-simulated reality. These headsets generate realistic images and sounds, engaging to senses to create an interactive virtual world. Augmented reality, augmenting the perception of the real environment with virtual elements by mixing in real-time spatially registered digital content with the real world. Pokémon Go and Snapchat filters are commonplace examples of this kind of technology used with smartphones or tablets. Augmented reality is also widely used in the industry sector, where workers can wear AR glasses to get support during assembly, maintenance, or for training. Mixed reality. This term includes both augmented reality and augmented virtuality. It blends real and virtual worlds to create complex environments, where physical and digital elements can interact in real time. It is defined as a continuum between the real and the virtual environments but excludes both of them. Now we will be looking into extended reality and convergence. At some point in the future, we envision the convergence of the smartphone, mobile VR headset, and AR glasses into a single XR wearable. XR could replace all the other screens in your life, like that big TV in your living room. Mobile XR has the potential to become one of the world's most ubiquitous and disruptive computing platforms, similar to the smartphone today. The confusion around XR technology is that the term is overused. As with other umbrella terms in the past like digital or natural, there is a bit of a marketing gold rush in play as every big tech company hustles to brand their latest gear with the up-and-coming moniker. In this section, we will look at how extended reality differs from other forms of realities. Extended reality versus virtual reality. Virtual reality is a subset of extended reality. VR is an immersive computing or gaming experience where the user's entire field of vision is filled via the device's display. In some cases, this is as simple as a headset your smartphone fits into, so the phone's screen sits an inch or so from the viewer's eyes. But while all VR is XR, not all XR is VR. For instance, Augmented reality may use your phone's camera to superimpose game characters onto your smartphone's display, as if the character was in the room with you. That's AR, and it's also XR, but it's not VR. Extended reality versus augmented reality. Augmented reality is also a subset of extended reality. AR captures live video of a device's surroundings and then adds visual elements to it, such as a Pokémon Go character in your living room, a tiger in Google search, or educational markup to your surroundings in a workplace or a historical area. Again, while all AR is XR, not all XR is AR. That is, you may play a VR video game with your phone in a VR headset. That's VR, and it's also XR. But it's not AR, because there is no augmented slice of the pie. You are not superimposing anything from the digital world onto a display of your surroundings. Mixed reality versus extended reality. MR or mixed reality is a blend of two popular types of XR tech, VR and AR. To zero in on the terms, VR is immersion, such as when you use a smartphone screen in a headset to fully immerse yourself in gameplay. AR is augmentation, such as when you use an app to superimpose a digital tiger in your living room with your phone's display. MR would technically be a blend of both VR and AR, but the terms AR and MR tend to be interchangeable. However, there is a clear difference between MR and XR. In short, all MR is XR, but not all XR is MR. For instance, a smartphone tape measure app is both MR and XR, while a VR video game is XR, but not MR. Let us now look at the major challenges faced by companies developing extended reality. Number 1. Cost. Cost is the most prominent challenge that is faced by companies developing XR. The XR devices are very costly. Since many technologies are working together, a lot of hardware goes into the making of these devices. The cost is very high. If the cost is higher, common masses may not be able to use this product, and companies developing would not able to increase their sales. This would not motivate the investors to invest their money into XR. Number 2. Hardware. Developing the hardware of XR devices is also a challenge for companies in this field. Since a lot of technologies, software components are being used, making hardware is a difficult task. The hardware should just not be robust but also be compact and able to process a lot of information very quickly and swiftly, and on top of that, the hardware should be cheaper. Number 3. Privacy. Privacy is a challenge being faced both by the users as well as the companies. Since XR devices are required to create an environment based on the user requirement, a lot of private details might be needed to create a user-rich environment. Storage of such data can be costly on the company's side. Privacy of the information can be a worry on the user's side. Now, we will have a look at what extended reality can do by combining virtual and real landscapes. Extended reality has a range of valuable use cases such as customer experience. With AR, companies can allow customers to try clothing, furniture, and other products, seeing what they look like in person before making a purchase. Virtual reality can create more engaging demonstrations for customers or provide useful ways for businesses to provide their customers with service and support. Training and development. XR is becoming particularly common in the educational landscape. In universities, teachers are using virtual reality to place their students in landscapes where they can interact with educational content. In the business world, AR, MR, and VR can all help employees to develop skills without putting them at risk. Remote work. Workers can connect easily to other employees, interact on shared content, and even work on projects collaboratively through XR devices. With MR and AR, specialists can even guide team members through complex tasks, like how to fix a problem on a piece of manufacturing machinery. Marketing and sales. Companies are extensively exploring opportunities for engaging with their customers through XR. Virtual reality showrooms are popping up around the world, and AR apps make it easier for brands to make their latest products stand out. Entertainment and events. Virtual reality events are quickly taking over as the new trend for the event industry. Similarly, XR environments can offer a wide range of valuable entertainment experiences by submerging users into immersive experiences. In this section, we will gain some insight about the future of extended reality. XR is gaining more attention all of the time in today's technical landscape, though there are still challenges yet to overcome. Companies investing in the future of extended reality will need to consider carefully how they can manage issues like expensive hardware. While affordable tools for extended reality are beginning to emerge in the modern market, the most advanced solutions can still be very expensive. Further innovation will be necessary to create products accessible to all budgets. Consumer comfort. Clunky, uncomfortable, and disorienting headsets can make it difficult for people to spend longer amounts of time in XR. Consumer comfort will be a necessity for the future of XR development. Security and safety. A lot of the benefits of XR rely on the ability of tools to safely transfer data and information. Security and privacy concerns will need to be addressed by tomorrow's XR vendors. Now we will be discussing virtual reality. Virtual reality, often shortened as VR, is the use of computer technology to create a simulated environment which can be explored in 360 degrees. Unlike traditional interfaces, VR places the user inside the virtual environment to give an immersive experience. To experience this kind of immersion, a VR headset is used. Some notable examples of VR headsets include Oculus Rift, Samsung Gear VR, HTC Vive, Google Daydream View, or Google Cardboard. These headsets remove vision of the real world and provide video to each eye, allowing for depth of vision. This technology is then supported by head and body tracking to connect the virtual world to what the user is seeing. Now, let us have a look at how VR works. Virtual reality makes use of computer modeling and simulation that enables a person to interact with an artificial three-dimensional visual or other sensory environment. VR applications immerse the user in a computer-generated environment that simulates reality through the use of interactive devices, which send and receive information and are worn as goggles, headsets, gloves, or body suits. In a typical VR format, a user wearing a helmet with a stereoscopic screen views animated images of a simulated environment. The illusion of being there, known as telepresence, is affected by motion sensors that pick up the user's movements and adjust the view on the screen accordingly, usually in real time, that is the instant the user's movement takes place. In this section, we will concisely go through the history of virtual reality. Although virtual reality may seem extremely futuristic, its origins are not as recent as we might think. In fact, many people consider that one of the first virtual reality devices was called Sensorama, a machine with a built-in seat that played 3D movies, gave off odors, and generated vibrations to make the experience as vivid as possible. The invention dates back as far as the mid-1950s. Subsequent technological and software developments over the following years brought with them a progressive evolution both in devices and in interface design. The term virtual reality was coined in 1987 by Zaro Lanier, whose research and engineering contributed a number of products to the nascent VR industry. A common thread linking early VR research and technology development in the United States was the role of the federal government, particularly the Department of Defense, the National Science Foundation, and the National Aeronautics and Space Administration. Projects funded by these agencies and pursued at university-based research laboratories yielded an extensive pool of talented personnel in fields such as computer graphics, simulation, and networked environments and established links between academic, military, and commercial work. Now, let's look at the characteristics of virtual reality. Believable, you really need to feel like you are in your virtual world, on Mars, or wherever, and to keep believing that, or the illusion of virtual reality will disappear. Interactive, as you move around, the VR world needs to move with you. You can watch a 3D movie and be transported up to the moon or down to the seabed, but it's not interactive in any sense. Computer-generated, only powerful machines, with realistic 3D computer graphics, are fast enough to make believable, interactive, alternative worlds that change in real time as we move around them. Explorable, a VR world needs to be big and detailed enough for you to explore. However realistic a painting is, it shows only one scene, from one perspective. A book can describe a vast and complex virtual world, but you can only really explore it in a linear way, exactly as the author describes it. Immersive. To be both believable and interactive, VR needs to engage both your body and your mind. Paintings by war artists can give us glimpses of conflict, but they can never fully convey the sight, sound, smell, taste, and feel of battle. You can play a flight simulator game on your home PC and be lost in a very realistic, interactive experience for hours as the landscape will constantly change as your plane flies through it. But it's not like using a real flight simulator where you actually sit in. In this section, we will explore the types of virtual reality. Fully immersive. For the complete VR experience, three things are quintessential. First, a plausible and richly detailed virtual world to explore, a computer model or simulation, in other words. Second, a powerful computer that can detect where we are going and adjust our experience accordingly, in real time, so what we see or hear changes as fast as we move, just like in real reality. Third, hardware linked to the computer that fully immerses us in the virtual world as we roam around. Usually, we would need to put on what's called a head-mounted display with two screens and stereo sound, and wear one or more sensory gloves. Alternatively, we could move around inside a room, fitted out with surround sound loudspeakers, onto which changing images are projected from outside. Non-immersive. A highly realistic flight simulator on a home PC might qualify as non-immersive virtual reality, especially if it uses a very wide screen, with headphones or surround sound, and a realistic joystick and other controls. Not everyone wants or needs to be fully immersed in an alternative reality. An architect might build a detailed three-dimensional model of a new building to show to clients that can be explored on a desktop computer by moving a mouse. Most people would classify that as a kind of virtual reality, even if it doesn't fully immerse you. In the same way, computer archaeologists often create engaging 3D reconstructions of long-lost settlements that you can move around and explore. They don't take you back hundreds or thousands of years or create the sounds, smells, and tastes of prehistory, but they give a much richer experience than a few pastel drawings or even an animated movie. Collaborative. What about virtual world games like Second Life and Minecraft? Do they count as virtual reality? Although they meet the first four of our criteria, believable, interactive, computer-created and explorable, they don't really meet the fifth, they don't fully immerse you. But one thing they do offer that cutting-edge VR typically doesn't is collaboration, the idea of sharing an experience in a virtual world with other people, often in real time or something very close to it. Collaboration and sharing are likely to become increasingly important features of VR in future. In this section, we will have an overview of VR equipments. What differentiates VR from an ordinary computer experience is the nature of the input and output. Where an ordinary computer uses things like a keyboard, mouse, or, more exotically, speech recognition for input, VR uses sensors that detect how your body is moving. And where a PC displays output on a screen, or a printer, VR uses two screens, one for each eye, stereo or surround sound speakers, and occasionally some forms of haptic feedback as well, like touch and body perception. Now, let us have a look at some applications of virtual reality. VR is being used in multiple domains like dining, medicine, media, education, entertainment, architecture, industry, arts and culture, and military. That was it for today's topic on virtual reality. In the next video, we will discuss augmented reality.